The solar panel is a Sharp brand On Energy 198 watt. Its model number is ND198UC1. It's November Delta 198 Uniform Charlie 1. You can pick these up online new for anywhere from $600 to $750, but if you watch eBay, you can find these for $400 to $500 shipped. I paid $400, including shipping for that one, and it's only about a year old. Next, we have the Enphase microinverter, the silver box. That's the D190 series, rated at 240 volts. You supply it with about 240 watts, you'll get about 190 watts out. With this system using a 198 watt panel, I'm going to guess I'm going to get probably 150, 160 watts out of it. These sell new for about $200 online, but if you watch eBay, you can pick one up for around $100. I picked this one up for about $80. And over from it, we have the installation kit. Best price I could find online was about $70. And that's what will be used to connect the microinverter to the extension cord that plugs in. It uses Tyco connectors, Tyco. I tried looking for connectors, just the connectors themselves, but I didn't have much luck finding affordable ones. So I ended up just buying the installation kit. Next, all the other little accessories there are things I bought at Home Depot. The connector, the little PVC box, the wire nuts. That's about $25 worth of parts. And then the extension cord, that's a 12 gauge heavy duty rigid brand. I picked that up at a garage sale for $10. I'm going to cut the ends of it off, and that's going to be my cord connecting the panel to the house. So overall, everything you're looking at here to get you started is about $585. And when it's all done, you can add more microinverters and plug them into, they all string together. You can plug them into the one microinverter that's right here. It has a connection for connecting another one to it, and you can connect up to 15 according to the specs. The Enphase installation kit, it gives the wiring diagram, the connector. We're using the 240 volt. So we're looking at the black and the red, and then the blue is the neutral. It shows a pinout of the connector that goes into the microinverter. If you need any other information on this, you can follow this Enphase Energy link. This is enphaseenergy.com/getting started. They have other manuals and documentation. Okay, I've wired the box. I ended up using 1/2-inch compression adapters, a little rubber piece inside. I had to drill out the rubber piece a little bit to accommodate slightly thicker wire. The 3/4 inch size that I bought was too large, so I had to make the 1/2 inch work. I just took a female adapter and glued it right into the box. And the wiring, we have the extension cord's green ground going to the Enphase blue neutral. They have the blue neutral has a white covering on it for some reason. And we have the extension cords black going to the Enphase cable black, and then we have the extension cord white going to Enphase red. Now we're ready to put a cover on it and move on to the next part. And here we have the cover installed. And while we're working in this area, I think it's important to mention that the Enphase microinverter circuit is rated for 15 amps. If you're going to be plugging this into an outlet or a circuit that's rated for 20 or 30 amps, you're going to need to install over here a dual pole 15 amp 240 volt breaker. That way it protects your Enphase circuit from overload or, you know, short circuit. Anything like that should happen. Okay, here I have, on the other end of the cord, I have a 240 volt outlet, and I've wired it to match the wiring of the plug. As you can see, I don't have the circuit turned on here, but we have the white goes to the white on the other side, the black to the black, and then the green goes to the ground. Now we'll put this together. Okay, now we're going to attach the Enphase microinverter to the solar panel. I got the microinverter attached to the back of the solar panel. I use some nuts, bolts, washers, lock washers. Just drilled some holes in the back of the frame of the panel. Next, we're going to be connecting the solar panel to the microinverter. These are MC4 connectors. Once you plug them in together, you need a special tool to remove them. They are waterproof. Next, have to find a spot to angle the solar panel. The closer you can get the sun to be pointing at the center of the panel, the better. You'll get the most output that way. So for sake of demonstration, we're just leaning it up against the fence right now. But you can lean it up against a chair, or you can even make a little a wooden support for it. So I've connected my cable to the microinverter. Now we're ready to plug it in. Alright, and we have plugged in the panel and the microinverter. Found out I had to wait about 300 seconds before it would start producing power. So the movement you're seeing is actually power moving from the solar panel into the house. It's turning this meter backwards. This is a meter that is dedicated to that outlet that you saw outside. We're going to look at another meter here in a moment, which will actually show, it's configured for bidirectional. It'll show power coming into the house from the panels. It'll also have a separate screen to show power going out to the outlets if I ever need to use the outlets for something else. Okay, the microinverter is now sending power back into the home, and as I had mentioned, we now have an arrow pointing to the left, which means power is moving into the home. Next, we'll start seeing little dots near the arrow, and those dots will be moving in the direction of the arrow. Each dot represents 7.2 watts. we have our first dot. Second dot.